Hello, this is Carl Urbanik here with the Lab 5 Interim report video. So I finished task 1 in the lab period. So here's the PID code here, and I have my robot preliminarily set up here, and I'll get to the demo here. So let me just plug this in real quick to show the proportional control. Alright, so you see there was on its side, and it was really going there. So my IMU is located in the Z axis here. So thankfully this position here is 0, and then this is positive degrees and negative degrees. And I have that printed out here and as the position. So if I tilt it about 30 degrees and then tilt it the other way about 30 degrees, and you can see I have the proportional output there. So as I tilt it, it tells it to go forward more and correcting, or backwards depending on the direction. The direction's arbitrary, just you can see that the wheels will switch directions. And then I will switch the KP to be 0 and the KI to be 1. And then upload this. And so this code is based off of my own PID method that I tried writing. So it might not be fully correct, but this was my code. I'll have a little more detail in the report itself. And so the integral control part of this, it really stacks on the error. So you can see how there, when it's at negative 0.5 degrees already, but then it increases extremely quickly. And if it goes all the way over at 90 degrees, the output goes to 2000, which is capped at at 255 because of the analog, right? But it's still what my calculation is giving me. And so I will switch the KI to 0 and KD to 1 to show that. It's just uploading here. And the serial monitor starting. Alright, and so the derivative calculation, it gave me really small values the way that I calculated it, which was by using the error from the distance between the set point and where the current position is, which is used by finding the IMU position, and then dividing the error minus the previous error, and then divided by the elapsed time between those two calculations. That's how I get the derivative position here. And so it gives me a very small value. So I'm assuming, if my ideology was right, that I'll have a pretty large KD and a pretty small KI in the final tuning of the code. If not, then I'll have to make some adjustments to make this these calculations here actually correct. But I think that my derivative calculation is pretty legitimate, as well as the integral. So I hope that I can just do some more final tuning in the with the KI, KP, and KD values. And So yeah, that is the interim report for Lab 5, the inverted pendulum robot.